Okay, so our fourth type of Punnett square is called a sex-linked trait cross. It's called this because these are traits that are linked to either the X or the Y chromosome, which we collectively call the sex chromosomes. So these are traits that are part of either the X or the Y chromosome. An example of one of these things, again, real life example, would be that color blindness is a X-linked disorder. So it's a defect of the X chromosome. If you remember, if we go down here to look at my Punnett square first, females have a XX chromosome combination. Males have an XY chromosome combination. And so before I did anything, I wrote out my Punnett square and I filled in my X's and Y's and did the Punnett square just for the X's and Y's. So again, this is a nice thing to do to start. It saves you having to think about two things at once later. So most of these sex-linked disorders are recessive. So that's going to be important as we set this up. So it's an X-linked disorder. So you guys are going to see me writing things on the X chromosomes. I'm going to ignore this Y because it's not a Y-linked trait. So the Y is just along for the ride, kind of. So color blindness is recessive. So I'm going to write, so again, this is in humans. I'm going to write colorblind, and I'm going to write recessive. So if colorblindness is recessive, then what's dominant? I'm gonna call it unaffected. If you want to think of it as like quote unquote normal or like seeing color or whatever you want to think of it as, that would be fine. But I'm gonna write unaffected, as in it is unaffected by colorblindness. So that unaffected is our dominant characteristic. So the same as we did before with complete dominance, we have an uppercase allele for the unaffected trait, and we have a lowercase allele for the colorblind trait. So in the problem, so these are going to ask you some different questions than what the previous Punnett squares did. It says a couple wants to know what % chance they have of their future children being colorblind. The mother is a carrier of colorblindness. So what it means to be a carrier is that you have the trait for colorblindness, but you also have an unaffected allele. So when you see carrier, think heterozygous. So for mom over here, mom's going to have, and you write the letters on kind of like exponents. You're going to have mom having one dominant allele and one recessive allele. And it says the father is unaffected. Well, we said unaffected was an uppercase A, so he just gets one. Remember, it's not a Y-linked trait, it's an X-linked trait. So the Y is just, we're done with that Y. So now we can fill this in on our square. And really, this is done just like a regular Punnett square. You just have to attach it to the X's. So this A comes here, that A comes here. This A comes here, and that A comes here. And this A comes here and there. So it was just like a regular Punnett square. We're just using it on the X chromosomes. Okay, so now let's answer our questions. Percentage chance of a boy with color blindness. So the first thing you got to see is that those aren't boys. XX is the chromosome combination for females. So these are our boys. Percent chance of a boy with color blindness. Well, this one is unaffected. This one has color blindness. You only need one A since there's only one X. So percentage chance of a boy with color blindness, well, 50%. One of them has it, one of them doesn't. Percentage chance of a girl with color blindness. So now we're just looking up at these two boxes. Both boxes have at least one uppercase A. Uppercase A was unaffected. So this couple will never have a girl that is colorblind. And then the chance of a child being a carrier of color blindness. Well, boys can't be carriers, but they're still a child, so they count. So the percentage chance of a child being a carrier, this one's not a carrier. Boys can't be carriers, but that one is a carrier, having the dominant and the recessive trait. So percentage chance of a child being a carrier of color blindness would be 25%. And so that's how you do a sex-linked trait cross.